this is part of the lecture for multivariable calculus, and I'm going to talk about lines now. How to find equation of a line using a point and a parallel vector to the line, and also using 2 points on the line. So let me start. For writing equation of a line, we need two things. First, a point on the line, and also a vector in the direction of the line. Or we can say that a vector that is parallel to the line. We show that by L, by capital L. And now let's see, if I have this line in here that passes through the point P0 with the coordinates x0, y0, and then z0, and if I have a vector v with the components a, b, c, then any points on the line, I can write them as the combinations of P0 and V. How? I say that, okay, I have the origin in here, and I consider OP0. So I'm going to say OP0, it's this vector. If I have just one copy of V, I get to this point on the line. So plus V is a point on the line. If I have two copies of V, then this point would be, let me graph it. This point in here would be OP0 plus 2V. Okay, so it would be OP0 plus 2V. If I have just half of V, so I would be here, and I get OP0 plus half of V. If I have it in the other direction, it would be OP0 minus V. That's why we say that every point on the line, I can get it as OP0 plus T, a parameter T that ranges through all the real numbers, times V. Okay, this is all the points on the line. So if I have just O P is just, let me graph it. I have P0, and then I have V. Then any point P with the components x, y, z has this equation. So it would be x, y, z, it's equal to OP0, which would be x0, y0, and then z0, the components of P, P0, plus T, the components of V. A, B, and then C. Okay, so x, the first component would be x0 plus TA. So x would be x0 plus TA, y would be y0 plus TB, and z would be z0 plus TC. So now I can say that this is called parametric equation of line passes through the point P0 with the components x0, y0, and z0, and it's parallel to the vector V, A, B, C is this. It would be x, y, and z. X would be x naught plus ta, y naught plus tb, and z naught plus tc. So basically, if you want to memorize that, you're gonna add the points on the line. Actually just one point is enough, point on the line, to the t is the parameter that ranges through all the real numbers, and then the components a, b, c of the direction vector. Here, direction vector L in here. Okay, so this is parametric equation of a line. Now, if we just find t from each one of them and set them equal to each other, we're gonna get the symmetric equation of a line. Look at here, I'm gonna isolate t in here. I'm gonna bring x naught, which is just a number on one side. It would be x minus x naught, and I'm gonna divide it by a. I'm gonna find t from here, which is y minus y naught over b, and I'm gonna find t from the third coordinate. I'm gonna get z minus z naught over c. If I set all of them equal to each other, which is x minus x naught over a, all of them are t, right? Y naught over b, and then z minus z naught over c. This is called symmetric equation of the line. Symmetric equation of the line. Okay, so how do we get that? By just eliminating t, the parameter t. Okay, x, y, and z are variables, and all other things are just numbers. Okay, now how can we find equation of a line through just 2 points on the line? So I'm gonna give you one example. Find a line through 2 points, through points A with the coordinates -8, 1, 7, and B with the components 4, 5, and then 6. Okay, so I want to find equation of this line that passes through the points A and B. For finding a line, we need a point. We just have one of them, so I'm just gonna pick A, and a directional vector. What is the direction vector in here? Would be this vector, AB. So I'm gonna set the direction vector to be the vector AB, the vector that is passing through 2 points. So AB would be the components of b minus a. It would be 4 minus -8, 5 minus 1, and 6 minus 7. So I get 12, 4, and then -1. Okay, this is the direction vector, and now I pick the point A to be the point on the line. You can also pick B, we get the same line, and then parametric equation of the line would be this. The x coordinate would be the x coordinate of the point plus t 12. I can write also 12t. Y would be 1 plus the coordinate of the direction vector, and z would be the third coordinate of the point that I pick, and then -1, and then times t. This is parametric equation of the line. You can also write it as a symmetric equation. How it would be x minus the coordinates of the point, which is +8, over the components of the direction vector, y minus 1 over the component 4, and also z minus 7 over -1. We can simplify that a little further if you want. Okay. On the next video, we're going to talk about how lines and planes are interacting with each other.